Hi, I'm Lauren, and we have another question that was posted by a student. This is about magnetic flux and turns of wire and current and resistance and Webers and all types of stuff. So we want to know, what is the magnetic flux, or the magnetic flux that passes through one turn of a 15-turn wire. I think that's key right there. The magnetic flux is only passing through one of the turns. So instead of having 15 turns here, it needs to be one turn. It's only telling you the flux through one loop, right? It does have 15, but it's only telling you the flux through one loop. Okay? So if we use our EMF equation, the EMF, or Faraday's law, is equal to negative N times the change in flux. So we need a delta flux over a delta T. And if you're in the calculus version, it would actually look like this: d flux over dt as a derivative. But this one works just fine without the calculus. So we're going to rewrite this as the deltas become finals minus initial. So flux final minus flux initial divided by T final minus T initial. And you have to be a little careful here reading through this question. It's written a little weird. So the final one, it changes to 3.51 from 9.63. And we've got units of Webers, which is, if you break it down, is a volt second for a Weber unit. And then we know the average induced current in the coil is 287, and it's asking us for the resistance. So this equation right here, Faraday's law, is just giving us the EMF. And when teachers and professors ask questions about Faraday's law, they love to use resistance and current in it to remind you that you still have to remember this equation. You still have to remember Ohm's law. V equals IR, or EMF equals IR. So if we were to use that in the below equation, you could then solve for R because we are given I. So plugging in some of these values, I'm just going to write IR for our EMF is equal to N. That's a -1. It's only giving us the flux through one coil. And then the final value is 3.51 minus 9.63. Make that a bracket. And then final minus initial is just the difference in time, because our initial time we will assume is 0, 9 seconds. And the units for Weber is, again, volt seconds. So on the top, you're going to get volt seconds. On the bottom, you have units of seconds. And so the seconds are going to cancel out, and you're going to be left with units of volts, which is exactly what we should get. Current times resistance will give us a volt answer. So running these numbers through, hold up a second. I should have done this before, and I didn't. Nope. 559. So I am getting that IR is equal to 109.48. And dividing both sides by the current being 287. And so I'm getting a value of the resistance is equal to 0.381, which is not the value of 5.7 that you said it's not the answer to. You will get the answer 5.7 if you use N equals 15 turns. So there you have it. Read those questions carefully because they're kind of trippy. It tricked me first too. So happy studying, everyone, and let me know if you have any questions.